Hi, I'm Isobel Lawrence. This is my poster about CryoSat 2 Sentinel-3A merged freeboard product, its sensitivity to weather events and what it might tell us about Ku-band radar penetration. This is building on work I did during my PhD at UCL, and I also presented some of these results at EGU that some of you might have seen. So the kind of basis for this work is in my paper, which I've put down here. In which I demonstrated that Sentinel-3A radar freeboard was consistent with CryoSat 2 radar freeboard, and that allows us to kind of merge freeboards from CryoSat and the two Sentinel-3 satellites, which gives us a denser spatial coverage over the polar region. So previously, when we've had to take a month of, for example, CryoSat data to get a picture of the entire Arctic, we can now look at we can now derive radar freeboard on shorter timescales. So in this work, I have been looking at variability in radar freeboard over 9 days. So that's a kind of synoptic timescale which will allow us to look at things like weather events. And so this is some of the work I presented at EGU. So this was for the previous winter, 2018-19. And I was looking at the changes in radar freeboard over the first year ice zone here in red and multi-year ice zone here in purple. And I found this really striking correlation between radar freeboard and snowfall from ERA 5 reanalysis over the same region. And the reason that was surprising was that conventional assumptions with Ku-band radar is that it penetrates, the pulse penetrates through to the snow-ice interface. And if that were the case, then we would expect to see radar freeboard decreasing with increasing snowfall. And we see the opposite, which suggests that the radar pulse isn't penetrating, perhaps not even to halfway through the snowpack. So I repeated that analysis for this winter just gone, 2019-20, but I included November in that analysis. And that means that there's actually less within the first year ice, there's less sea ice in the Chukchi Seas because it hasn't frozen up there yet. So we have a kind of smaller region over which we're looking at variability, and I think that is a kind of detriment to the analysis, and maybe I want to start looking from the 1st of December again. But the correlation, I guess, doesn't stand out as much as it does in this plot, but you can see there's still peaks essentially seem to line up. And kind of the same is true over multi-year ice. Again, radar freeboard sort of increasing with increasing snowfall. And there is sometimes this kind of offset between the two, which I wonder is whether that's because of kind of day uncertainty or like time uncertainty in the ERA 5 reanalysis data. And I'd be interested to hear from anyone if anyone's got any thoughts on that, actually. So then an extension to the work that I've previously shown is including a comparison to temperature. So this is just average temperature over 9 days from ERA 5. Obviously temperature and snowfall will also be correlated, but there is a correlation with radar freeboard. It kind of stands out again less than the snowfall correlation. But for example, here over multi-year ice for this winter just gone, there's definitely again, kind of peaks corresponding with peaks. So radar freeboard increasing with increasing temperature. That might be the snowfall, a kind of another way of looking at the snowfall correlation. And I haven't yet really quantified any of these correlations because this is all very new work. Finally, I did the same for wind speed. So I just averaged the U and V wind vectors from ERA 5 to get a magnitude of wind speed. And the kind of idea with this was that maybe snow redistribution by winds can also change the radar freeboard signal, partly because of the snow being thicker after redistribution. But yeah, again, it seems to correlate, in particular over first year ice for last year and over multi-year ice for this year. So I'm going to kind of wrap up now, but yeah, this is all really preliminary, and I haven't really quantified any of these correlations or looked in more detail at the kind of spatial, how the correlations are varying spatially, which I think would be interesting. I'd be really happy to hear from anyone who might have some feedback or suggestions or questions. Yeah, thank you for listening.